All right, so forgot to do a couple of one main example, but there are two examples we could do with this. Um, Finding the difference quotient. So this is basically finding the slope between two arbitrary points on a curve. So if we have uh, some curve that looks like that, this is basically finding the average rate of change between any 2 points. So if we had, say, this point, and we'll call that, say, x is a right there, and we want to go some distance away from that, and we'll call this a plus h. And a is just whatever the difference is between a and that new point. And what would be the slope of that line? So if we were to turn this into a slope formula, so the y coordinate would be f of a, the y coordinate here would be f of a plus h. So the difference quotient it's a slope formula. So there is the y value for that first point. And we can subtract the y value for the second point, which would be right there. And then we can subtract the x values for those 2 points. So a plus h minus a. And of course, that simplifies. The top does not simplify. So these are just two function values. And then the bottom does simplify. A plus h minus a. The a's will cancel and we'll just have h. So here is our difference quotient. And so when it says find the difference quotient, we are basically just going to plug in for this formula. And it could be less complicated or more complicated depending on the type of function. If you ever see this with the linear function, since this is talking about slope, then the difference quotient is just the slope. So the slope on a linear function is constant, and so we don't really have anything to calculate there. You can plug it into this formula, and it'll simplify down and just give us the slope. But when we have a curve like this one, so this is a quadratic function, and so this would look something like that, oriented in some way. We'll have to do a little calculating and find the difference quotient. And the hard part of this is really just the algebra. There's not too much else besides simplifying this down. So we're going to use this formula. So we need to find f of so f of a plus h. And so to do that, we're just going to plug in a plus h for each x that we have. And then we just need to simplify it. So let's FOIL out a plus h squared, and we get a squared plus 2ah plus h squared plus 4a plus 4h. We can distribute 6a squared plus 12h plus 6h squared plus 4a plus 4h. Then we need f of a, and so f of a, we're just going to plug in a for the x. So we have 6a squared plus 4a. And so now we're ready to use this formula. And so scroll down a little bit. So f of a plus h minus f of a over h. And so here we have our f of a plus h. And this is where you gotta be careful with all of your terms here. Make sure you get them all. And then so there is our f of a plus h. And we need to subtract off f of a, which is just that. So 6a squared plus 4a, and then all of this is over h. Now, when you do this, well, when you simplify the top, anything without an h is going to cancel. So we have 6a squared minus 6a squared. Those are going to cancel off. No other ah term, no other h squared term. We have 4a minus 4a, so those are going to cancel. And then we have 4h. So we're only left with these three terms that have the h in them. And it will always work out that way. So if you ever do this and you start simplifying, you realize you have a term without an h when you're on this step, then probably you did something wrong. So let's see what we got left. So 12ah plus 6h squared plus 4h over h. And now what we can do is we can factor out the h in the numerator because we need to get rid of this on the bottom. And you're going to do problems like this in calculus when you get to limits and derivatives. And basically what we want to do when we get to calculus is see what happens when h approaches 0. And so a lot of times we want to get rid of that h in the denominator. So let's factor out an h on the top. We have 12a plus 6h plus 4 all over h, and then our h's will cancel, and our difference quotient is 12a plus 6h plus 4. And so that seems like a lot when we first do it. And it is. I mean, it's not nothing for sure. But the more you practice this, the more you will start to see kind of where everything falls out. So like I said, any terms in here that do not have an h are going to cancel out, and you're just left with the ones that do have an h. So that kind of once you get practice this a little bit, you can probably just forget about that first part and just write down terms here that have an h. You're not going to have any terms with an h here because we're just doing f of a. So f of a plus h does have terms with h in it, and then you just need to grab those and factor out the h, and there's your answer. And that is a 4. All right, let's look at one other one, and this next one is a rational function. So it's the same thing. We're finding the difference quotient. So we first need to find f of a plus h. So anywhere you have an x, you're going to plug in a plus h. So you have a plus h over a plus h plus 2. And then, of course, f of a, anywhere that we have an x, we're going to plug in an a. So now let's plug it into the formula. So f of a plus h minus f of a over h. And so now we're going to get kind of a complex fraction here, fraction within a fraction. So we have a plus h over a plus h plus 2 minus a over a plus 2, and that is all over h. And so now what we need to do is in this numerator of fractions, we need to find the common denominator. And so the common denominator is just a plus h times a plus 2. So we need to multiply this one. Well, so let's, normally the way I teach this, let's write our common denominator here. There is going to be our first term, and then here is going to be our second term with the same denominator. And so we have a plus h over here, and we added in an a plus 2 in this denominator. So we went from a plus h plus 2. Now we added in an a plus 2. So we need to add in an a plus 2 on top. Here we have an a that we started with. We had a plus 2 on the bottom. Here we had it in a plus h plus 2. So we need to put that on top. And then that is all over h. So now let's see where we can simplify this. So let's FOIL out our numerators. So a plus h times a plus 2, that gives us a squared plus 2a plus 2ah plus 2h. We'll distribute the a through there. So we have minus a squared minus a h minus 2a. And then what we can do, so we only have the one denominator now. We've combined our fractions up here into one fraction with the common denominator. And so what we can do, because this is essentially h over 1, and if you divide by fractions, we would be multiplying this by 1 over h. And so the h is with this denominator. So we're going to put the h right there. And so now let's see how this numerator simplifies out. A squareds will cancel. The two a's will cancel. And 2ah minus ah, that should give us ah, and then we have plus 2h. And down here, we have a plus h plus 2 and a plus 2. And so let's factor out the h in the numerator. And another part you want to make sure that you are aware of, proficient at. This goes with anything in this class or any other math class, is ideally, especially once you get past the homework and get into the quiz and the test, it always helps to know what your answer should look like. So I get it, a lot of times when I'm helping students and I'm doing a multi-step problem like this, we'll get to the next step and they'll say, well, is that the answer? And then we get to the next one, is that the answer? And of course, when you're learning this, you're not always going to know what the final answer might look like. But one of the things you want to try to get good at is knowing what the final answer does look like. So if you do these problems where you have a rational function and you're finding the difference quotient, you want to know what the answer should look like. Same thing with the quadratic that we did before. You want to know what that answer kind of looks like, and because you find the difference quotient for a quadratic function, the answer has the same form all the time. It's not going to be, like what we found a minute ago in one problem, and then we do another quadratic problem. It's going to be something completely different. The answers will look the same when you do similar type problems. So that's one thing to make sure that you're aware of, especially when we're doing these long multi-step problems. So the h's will cancel, and here the a plus 2 will cancel. And so now we actually just have 1 over a plus h plus 2, and that is our final answer. So these difference quotients, they will take a minute, especially when you're getting used to them, but they're not hard. It's just kind of a lot of algebra, and you got to be a little bit careful, make sure you're simplifying correctly. And like I said, kind of have an idea of what the answer will look like, so that you know when you should be done. So, but if you have any questions, feel free to email me.